Okay, let's do this and go live. Let's share the links to a few people. So let's go on Twitter, share it here. Area, great. Start off with a typo, that's awesome. And I close YouTube Studio. Okay, I'm trying to be quick, which isn't the best. Bum, 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 bum. So yeah, let's calm down. Let's see, go live. I'm already live. Let's see. This should be working now. Double stream key, nice. Let's see if this works. This one, okay. That's better. Okay, so let's share on my Telegram. Advent of code. And let's also share this on Discord with a few people. And then let's see. As I said, in an hour and 20 minutes I have an interview planned, so I can't make it very long. But yeah, let's just tell a few people that we're streaming, try to see how far we can go. And after that, we might have to cut it short and pick it up later, because the interview has a set date and I need to prepare a little bit of stuff, so I need to stop a bit early. But yeah, let's just see how far it goes. So far we've been able to do this in about an hour or something, so yeah, let's see. Day 14, extended polymerization. The incredible pressures at this depth are starting to put a strain on your submarine. The submarine has polymerization equipment that would produce suitable materials to reinforce the submarine, and the nearby volcanically active caves should even have the necessary input element in sufficient quantities. The submarine manual contains instructions for finding the optimal polymer formula. Specifically, it offers a polymer template and a list of pair insertion rules, your puzzle input. You just need to work out what polymer would result after repairing the pair insertion process a few times. Okay. NNCB. Okay, and then we have a mapping here. The first line is the polymer template. This is the starting point of the process. The following section defines the pair insertion rules. A rule like AB forward to C means that when element A and B are immediately adjacent, element C should be inserted between them. These insertions all happen simultaneously. So, starting with the polymer template NNCB, the first step simultaneously considers all three pairs. Okay. The first pair matches the rule NNC, so element C is inserted between the first and the second. The second pair NC, let me see. So we have NN, NC, and CB. Okay, the second pair NC matches the rule NCB, so element B is inserted between the N and the C. The third pair CB matches the rule CBH, so element H is inserted between C and the B. Note that these pairs overlap. The second element of one pair is the first element of the next pair. Also, because all pairs are considered simultaneously, inserted elements are not considered to be part of the pair until the next step. Okay, after the first step of this process, the polymer becomes NC, NB, CHB. Here are the results of a few steps using the above rules. Yeah, that's called exponentially scaling, right? So yeah, that will become an issue very fast. This polymer grows quickly. After step 5 it has a length of 97. After step 10 it has a length of 3073. After step 10 B occurs 1749 times. C occurs 298 times. H occurs 161 times and N occurs 865 times. Taking the quantity of the most common element and subtracting the quantity of the least common element produces this. Okay, apply 10 steps of pair insertion into the polymer template and find the most and least common element in the result. What do you get if you take the quantity of the most common element and subtract the quantity of the least common element? Okay, so yeah, this will be tricky, and there's probably a trick for figuring this out that I'm not sure if I know, but yeah. let's see if we can work this out. I wonder if there's a pattern that emerges at a certain time. NB, CC, NBBB, C, and CC. Because this first one produces the same as the one that comes after. And CB introduces something new, the H. And HC, HB. And this one goes back to CB over here. So right over here it ends with CB again, and so then this pattern repeats itself. But yeah, how do you... That's a tricky one. There must be a formula for like recognizing how it expands, but yeah, it will be tricky. Let's just start with this one and see how far we go. AOC 2020. So let's copy day 3. Day, it's 14, right? Yeah, day 14. Boom, boom. 14. Okay. Program will start with day 14 as well. Yeah, I think I'll have an issue with part 2. But yeah, let's just see. For now, it's lines. The first start is first. Then we do lines that skip to select x that's split by, like this, as value tuple to list. For mapping is, and this actually is a list of string match string insert, right? How many times do we need to do this? 10 times? 10 steps. Okay. For int I is 0, I smaller than 10, increment I. Okay. And we do string builder. SB is new string builder, and we just loop this for int x is 0. Doesn't matter, not really. We can just do 1 x smaller than input dot length increment x. So we do string. We can sb.append. Not that input. Actually, we need to have mapping dot length for each. No, wait, we need to have this needs to be a lookup actually. Var. Let's do to dictionary. Item 1, item 2. So this is the mapping. So what we need to do is we need to walk to the current string, and this will be the lowercase start actually. Can name it input actually, just lowercase input is fine. And what we need to do is we do input x minus 1, we append that to the string builder. We need to have a string to make the pairs, so we do string pair, we do pair is new string new char, and we do x minus 1 input x minus 1, comma come on, and input. Right, so this is the pair that we're looking for. Then we do mapping.tryGetValue pair out to insert, and we do if like that. We first do the one that we passed. We can insert that one, then we do that part, and then we add the one after it, and this one goes in between. Out var, this is a string, and we do sb append to insert, right? Now we do console.writeLine. We need to actually, yeah, I can do console.writeLine input. Here we do input is sb.toString, sb.clear. So we have that. Can actually write it out every time. And now we do input to char array group by xx to dictionary x key x count. So var counts is this, and this will actually need, yeah, it's individual characters, so that is fine. And then we do counts order by accept value. Var ordered is this, and we do var smallest is ordered first, var biggest is ordered last. Then we do console writeLine smaller, basically biggest, right? Biggest, this one, smallest, that one, result on that. So we do biggest, and we do biggest dot key, biggest dot value, smallest dot key, smallest dot value, result will be biggest value minus smallest value. Okay, so this is part one, should be part one. Let's switch to the test input to see if I'm correct. And we do lines is 2 lines, no. Just override it like that and see what it does. Wow. I did 10 steps and this one was 4, right? So I need to limit this to 4 for the test input. So let's see if this is what we see here. This already wraps around. So let me see if I'm correct. I don't think so. I think there's something wrong here. Let me see. So I have an extra value in here. Let me walk that just to see what I do. I mean, the basic version works, but I added twice. I don't need to, yeah. So what I need to do is add the first one and then do this and then add the other one. So this one should be better. I already saw my mistake. NCN CHB. Yeah, I think that's it. After 5 times, after step 10. Okay, so first step 10, I just need to not write it out. But let me see, I can remove this, still do it 10 steps. And then see if my values are correct. Biggest is B with 40 and 16. Okay. It's not. Let me see how the length goes. Four, 6, 8, 10. Let me see if I still write them out and I stop at 4. Let's see if it's at least the fourth step matches still. Or if there's a bug there. There is a bug there, okay. So it goes correct up until here. Right? Which is interesting. So let me see, is the previous one wrong as well? Come on, let's remove the screen. I need to copy this. Okay, that's weird. So this one is correct. So how come from this step to the next step there is a bug? Interesting. So my logic worked for the first step, second step, third step, but step 4 is wrong. How is that possible? Let's see. Note that the pairs overlap. The second element of one pair is the first element of the next pair. Also, because all pairs are considered simultaneously, inserted elements are not considered to be part of the pair until the next step. After the first step of the process, it becomes this. That's weird. Kind of wanna. I'm just thinking, how could this be an issue? It's really strange. This never hits, right? There's not something that it hits a pair that it can't find. It hits a pair that it can't find. CH. CH is over here. Why is that not in my mapping? It skipped, damn it. Okay. Okay. My 2 lines skips the empty lines. So now it will be correct. So now I can run it to 10 times. Okay. Let's keep this breakpoint here. Okay. 1749, 161. Answer is 1588. Okay. Why does it always have to be with debugging that I get to the answer? At least I'm good at debugging, because I always have stuff like this. Throw new not supported happen. Should not happen. Let's just do it like this. Now we can switch back to the real input. Boom. Boom, 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 and we can stop writing out this part and just throw out the answer, except we have an error. 3587, okay. Okay, part 1 done. The resulting polymer isn't nearly strong enough to reinforce the submarine. You need to run more steps of the pair insertion process. A total of 40 steps should do it. I was afraid of that. In the above example, the most common element is B. Jesus. Apply 40 steps of pair insertion to the polymer template and find the most and least common pair in the result. What do you get? Blah, 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 blah. Okay. Yeah, this is horrible. So there is a trick to that probably that I'm not gonna get. So just be prepared for that. Let's see. Console, that right line. Processing step I plus 1. I just know this is going to be an issue for something. Probably the string builder won't like that as well, but yeah. See, then it starts crawling. I'm not even sure if I set 46-bit compilation yet. So there will be a trick and like a pattern finding thing. So right now it's just doing lots of memory mapping and all sorts of stuff. So yeah, I still have a good 50 gigabytes of RAM free, but that's not what's supposed to happen. Usually there's like a process where this becomes a repeating pattern. Dun, 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 dun. So yeah, this won't run like this. Let's see. If input contains let's just start here. Oh Jesus, it doesn't even get back to the first original. So there is never a step where it just goes back to this. So there's like an always expanding algorithm here. And I don't know how you would do this. Yeah, auto memory exception. Okay. So let's do this. Dun. For each so if we cannot simulate it, maybe we can see the like a pattern emerging here. Alright, so let's just do pause break. Is there any relation between these numbers? Oh. And at which point will I figure it out? Okay, so let's see. I probably need to diff them as well. Oh wait, it doubles. This one doubled here. If only it were that easy, right? Hey, wait. So from 14 it goes to, so this is times 2 minus 1. This is times 2 plus 1. This is times 2 plus 10. I think there will be a common factor that you can apply to this, but it will be hard to find. Especially since I'm just taking a stab at this. Because here we're like 20 steps deep and because these things keep creating stuff that exists before, right? So I'm just wondering when you'll, because there's probably something like once you've hit all of these, then it just starts repeating. But when have you used all of these? I don't even know. So I don't think this is something I can solve, because there's just a trick that you have to know. And I don't know it, and I don't see a clear pattern from this. Does the order even change? Yes, it changes. So in the end, does it stay stable? SOBK. So it's NHP CFV SOBK. Okay. So I wonder when that is established as the order. Because probably once that happens, it just... I'm just trying to figure out, is there a way to detect how this will increment? Like 2, 4, 6, 11. So this is 5, 5. And then it goes to 11. And then it makes a big jump. So my thinking is that there is like a pattern of how it increments with factors, but I just don't know how. How many characters does the occurrence did this have? The most common. Okay, so let's take. Wait, did they actually list how big it was? No, the actual length they don't even. Dun, 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 dun. Damn, that's a lot. So KB, MB, gigabyte, terabyte. Okay, right? So kilobyte. From here it's megabyte, gigabyte. So you need over 2 terabytes of RAM just to fit in these, right? If it's single byte characters. And this is actually Unicode, so there's even more stored probably. So there's no way to actually make that string, right? So the approach that we did here, it's impossible to do this. And I'm just wondering, because you can... Actually, I am an idiot. Because every pair always matches, so the length scales linearly, but it's predictable. It's just the total length minus 1 gets added, right? So from 3 you go to 7, then you go to 13, right? These are 6 additions, 2, 4, 6. So I can actually know the total length. The only thing I don't know is how it increases. Let me see. Let me see if I can figure this out. Bum, ba-dum, bum. The thing is, if there's like a repeating pattern that you can pick up, that you can then process in isolation and just do the parts that are next to it. So I can already tell you how long the string will be, because it's just every time it processes, it's just times 2 minus 1, right? So is there a way to recursively process all of this without storing the entire string? I'm just thinking. And even then, I think I could probably split it up in sections. That's just madness. I'm just thinking, because what I could do is I could go up to like step 10 and then build a new result, but after I've hit the length, just process another. Just thinking if I can split it up in multiple sections and then still do the processing. But it's so many operations. I think there is like a trick in a pattern, something. But I was just thinking I could work around the memory limit by just processing it in chunks, and I could actually parallelize it because I have so many CPUs, can put them all to work. But because the thing is, you can look at each 2 in isolation, right? So if you take this one and you want to do it in 2 pairs, you can just, like, if you want to do this, you can do, okay, let's just take half. And do this and still have it, right? So just take the last character and add a new one, and then it will still be good. I'm just wondering if it's doable memory-wise, right? Because I don't think we're meant to actually do the processing. You need to find like the pattern. There's a way to codify this and then just simulate a number of steps. Let me just Google to see if there is something for like the whole pair insertion. Pair insertion. No, I don't even know what to search for in this. So the only thing I can think of is to actually process these string in parts. But that would still be crazy. But yeah, I can do that. Dun, 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 dun. But I just think it's futile because there's no way this will work. Bum, 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 bum. No, what's it doing? Did I broke something? It's not even writing out the steps. Let me see. Break. That is weird. What happened? Console.WriteLine makes it not return. There's an issue with console.WriteLine. What the? Okay, there's something fishy. Okay, there you go. So you can do 20 steps pretty fast and then it starts. And this is probably because of all the allocations and stuff. I wonder. If I do if I smaller than 20. And this will just keep infinitely looping, right? But even then, at these lengths, you gotta think that every step is bigger than the previous. It doubles in length. Just thinking if it's worth it to try to write an algorithm that splits it up in text strings. It's really tough, this one. I should probably ask Luc. He fixed it. There's a former colleague of mine that was here a few days ago to do one of the Advent of Code ones. So yeah, the issue is that this grows so big that you can't do it in memory, and I can't really see a pattern from the increasing numbers here. So there has to be a way to calculate this without actually doing all the expansion. So there has to be a way to predict like all of these steps based on these rules, and I don't know what that would be. So the only thing I can think of is to let me mute quickly. Sorry. The only thing I can think of would be to split the string and then do that in parts. So then, let me see. I can do list string input is new like this, and just boom. Let me see, and then I need to do Let me just put this in the part 2, because this part 1 is just fine and it works. Let me just put this in the part 2 and start to mess around with this. and this one was 10, which is fine. This can be removed. This can be removed. Boom. Okay. So I was thinking to make it easier on everything and allocate smaller parts of memory. I don't even know if I've set this to 64 bits. Build x64. So that at least helps with allocating large amounts of memory. But I still think there should be like a repeating pattern that emerges at some point. I just wish I knew how to detect that. I should probably follow the chain and see if there will be a loop. Is there a moment when NN, because NB, let's see, NB introduces C, so then you can, let me see, NB, okay. So NB only expands, so it can never be anything other than NB. So you have NN and C, and then it becomes NB. Let's see. BB, CN, CC. So this is the CC, and then you have the CCNB. Wait, why does this keep repeating here? So you have the CCNB. I wonder. Man, this is a tough one. If anybody has any suggestions, feel free to let me know, because I'm running out of ideas, and I don't think this will work for the I don't think my string splitting idea will work, because it's just too big and too much memory. But I did find it fascinating to see like the NB that occurs here. It will always stay NB at the start. It will just insert B's in between, and those B's turn into B and B, because BB will produce, yeah, the N. So BB will produce B and B, so then you get BN, which will also do a B, and NB, which will be a B. Okay. So the B and B things will always just produce B's. Oh wait, that is a pattern. That is a pattern. So once you have BB, it will only ever expand to B and B and B and patterns. I wonder if we can isolate that part, because BB will be N, NB, so it will just be, once you hit a BB, it will only expand to B and NB. So that might be it. let's see. Notepad. So once you have BB, this becomes BNB. BN becomes BBN. NB becomes, let's see, NB becomes B. So that becomes NBB. So then you have BBN and BB. Oh, NN becomes a C. Alright, damn it. So then you have this pattern repeating. So BB to BB. No, BB becomes B and B, 2BB and NN. This becomes 2B and B. And what does the NN become? So NN becomes NCN, NC, okay, NC becomes a B, and CN, what does CN do? Becomes another C. C, so you get NBC and CCN. Okay, from here it's, But I was just thinking, you have B that does this, and a step after you have 2B and B. So I was thinking if you can find a pattern in that, because after that you get 2B and B. So you get B, B and B, then you get 2B and an NN, then those two B's give 2B and B's. And after that you get 4BB to NN. But the NN have shifted into something else. But no, because there will be new B and B's in there. So that's the way I'm thinking, if there's a way to reduce this. Need to watch the time. So we have NBC, which is NB and BC. Did we have that before? No. But I actually think that I'm on the right path here. Because you, instead of it always falls inside, so the existing outside pairs never change. So that's why I think you can look at them in isolation and see what they produce. So I was just thinking, if you can keep track of how one pair, what it does over time, you could actually just keep track of the pairings that it makes, and then from that calculate everything else. Maybe that is it, actually. That may be it. Okay, let me think. So we have dictionary. Am I correct? Let me think. So you have NN, NNCB. So this is basically NN, NC, CB, right? Whatever happens here, it doesn't have to change because these will so then you get NN becomes NCN. No, this becomes NC plus CN. And then you get right? I'm just thinking, if you keep track of the amounts of each and then just do these operations, you'll actually have it. So yeah, NN, what's the mapping for NN? N becomes C, so NC, CN. Right. So if you have an NN, you remove it and then you add these two. Then you have NC, this becomes, let's see, NC becomes NBC. So NC, NB, comma, BC. This is how you transform it. And then you have CB becomes CB is H, CH plus HB. Huh, that's interesting. I think this might be it. Okay. That is cool. Let me see. So now the mapping becomes var real mapping is mapping to dictionary x, so key, and then you get x, and this becomes string A, string B, and then you get new string, not like this, new string, new var array, and this becomes x0. Oh no, actually I need to know the key as well. Select. We do key, x at key, value, this becomes x dot key 0, comma x of value 0. And this becomes key 1. Don't think it really likes me anymore. A declaration that user value variable b. Okay. Just do it like this. Yeah, it doesn't like that. Okay, let me just do it like this. String. Let's just put a string format in here for the 2 parts. And then we do the same here. And I really need to keep an eye on the time, because I need a bit of time to set some things up as well. Boom. And I need an accolade here as well. Should probably do it new here. Right? It's not the way they like it. I can't think of the syntax right now. I think it's this. Something like this. To list. Actually, this will be to dictionary, key, value. Right? Okay. And this will be a dictionary string, comma, string A, string B. Real mapping. Okay. Whew. Yeah, we don't need the string builder anymore. Boom, 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 boom. Real mapping. Dun, 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 dun. Okay. Let me see. So now we make a dictionary. Actually, I can just do real mapping dot keys dot select. Actually, can do to dictionary x 0 var counts is this. Okay. What I can do now is start with the 2 pairings that we have here. What does the input start with? Is it also just one short string? No, it's a longer string. Okay. Doesn't matter. Let's see. We do for int I is 0, I is smaller than input.length, I plus is 2. Okay. Now we do counts input.substring I, comma 2. And let's just increment that. So even if it doesn't exist, it will add it, I think. So this will set up part 2. Let me just see if this all works as I think it will. Okay, we have an error. Count is not defined. Sure, all of this will have to be rewritten as well. Doesn't matter. That's pretty cool. If this works, I'll be very, very happy to have thought of this myself. Okay, so we have counts. Oh wow, that's a lot of... Jesus, that's a lot of pair mappings. Okay. Sure. Okay, so now what we need to do is to expand these 40 times. So instead of pairs, instead of all of this, just say F it. Just remove all of this, and what we do is for each var record in counts where x exit value larger than 0.2 list. I wonder if this will bite me in the ass because it needs to be yeah, I need to Hey, look, I actually think I've figured out something really, really cool, but I don't have a lot of time left to finish this. So we do a new version here, and we do new key is exit key, value is exit value. Okay, actually we do the select after. Boom. And now we do just entered. How far? I finished part 1 and then realized that I couldn't do part 2 because of memory. And now I realized that I can actually just treat this as these pairs which have this result. So if you look at NN, what it does is it adds an NC and CN pair. So I made mappings for every combination to see what it will spit out. And now I'm writing a loop to just go and do counts record dot key is actually, let's see, int let's see, so now we record dot value I'm just thinking because they all happen in isolation. Because you remove one to make the other. So yeah, I'll just do it and see if this works. Value dot a, no, because this is a 2-part string, right? No. Okay. Record dot key. I need to get real mapping. Try get value out var to produces else throw new not supported exception. Okay, fine. And now we do counts produces dot a plus equals record value b, and we do counts record dot key is 0. Let's just do minus is record dot value. Whew. Let's see. And I think this is actually it. See, and we'll do. And then I need to find out how I did. I created a dictionary string long int isn't enough. String is the polymer code. Yeah. Let me see. Good point. I can make this a long here. Let me see. Tutorial array. Blah blah blah. I have an interview in 10 minutes, so I'm kind of stressing. But I think I'll have to come back to this. But I don't think I will make this in time because I also need to. I will need to split up the values here. So yeah, for now, let me just do this. Yeah, and this will just write the biggest pairings, but I'll be happy if this works at all. So let's see what this does. Boom, KK, yeah, it actually works. Smallness is FV with 0 results. Okay, nice. So let's see what happens if I do this for 10. I want to run this on the test input actually. Man, I love that I figured this out and it worked. Smallest NN was 0. Okay, this is not correct, I think. Okay, so I have to come back to this to finish the last part, because I need to split these up into the 2 compartments again to see the actual individual counts. But yeah, I'm really happy that this seems to work. I think I'm on the right path, and I think this will work, which is really cool. So I'm really happy that I actually thought of this after staring at all these notepads for so long. So yeah, I think I'll end it here, and I'll probably get back to it after the interview just to clean everything up and make it work. So I'll stop the stream here for now, and make sure to get everything ready for the interview in 10 minutes. And then I'll be back online in about 10 minutes. But yeah, I actually got a way to do part 2, which I didn't think I would be able to. So I'm really happy with that. So yeah, I'll see you guys later. So give me 10 minutes. I'll get something to drink, set up the Zoom, and I'll finish this after the interview. So I hope to see you here in about 10 minutes. Bye bye.